Okay, for this last video we will focus on the period, which represents one wavelength or one full cycle of the given trig function. And so we really tend to think of one full cycle as being starting at the starting point and going to 2 pi. And if you remember, one length around the circle is 2 pi radians, and so basically that wave you could think of as the circle being rolled out over the course of or tracing a point around the circle one time. Now, if we kept tracing that point around the circle over and over and over again, it would create this kind of this wavy effect. Now, again, if we look back at the given equation, y equals a times sine of bx, the a and the b have understood values. Now, in this case, the b doesn't represent the period by itself. A represented the amplitude by itself. However, B is just showing us basically how quickly that full cycle is taking place, and so the frequency, I guess, of that cycle. And so the way we have to come up with this, since we know the length of the circle is 2 pi radians, we have to relate the frequency back to that. And so what we get is we get this equation that tells us that the period is going to be representative of 2 pi divided by this frequency of b. Now, notice we use the absolute value of b in this case because it is a distance, it is a length of the circle, and so we have to come up with a positive value. Now, what we have here in the first example is y equals sine of 2x, and so what that does, that 2 actually squeezes the cycle into a shorter time frame or a shorter frequency. And you can see if we divide the 2 pi divided by 2, it makes our frequency actually a full pi. So what happens here is this gets cut in half in effect, and so what you'll see is that the frequency gets squeezed, and you can see the effects it has on the actual graph. And so that's basically what you need to remember as far as pi is concerned. Now, as you move into advanced math, obviously they will go into much greater detail in regards to amplitude and period and frequencies. But this is a good introduction to trig graphs for you to understand as you go in. Now, sample problem 3, we actually have you instead of graphing, we actually have you doing some identification here of the period and the amplitude. So go ahead and try sample problem number 3 real quick, and then I'll give you a demonstration. Okay, so I'll take, even though we have 2 problems here, I'm actually going to break it up according to amplitude first and then period second. So if we look at amplitude of each of these, we know that we are dealing with the a value, and of course the amplitude has to be the absolute value of that, and so we get a positive length when we do this. And so if you think about amplitude of part A, that's kind of shrunk it in a little closer to the x-axis, whereas the amplitude of B has actually stretched it a little higher and lower and gotten a little further away from the x-axis. So you should be able to kind of get this visual of something like this versus something like this in your mind if you were going to be graphing that. So the period, on the other hand, is going to actually be 2 pi divided by the absolute value of the given b value. In this case, for part A, we have just pi, and of course the absolute value of pi is pi. Now, what happens here is the pi's get canceled out, so it leaves me a period of 2. And so basically this would kind of alter a little bit what you would see on your x-axis as far as the points being given. But right now all we're really concerned about is you just identifying these parts. And so for B, we have 2 pi over 1/2 pi. Of course, the absolute value of 1/2 pi is positive 1/2 pi. Now the pi's are going to cancel out, leaving us 2 divided by 1/2, and we would make that 2 times the reciprocal of 1/2, which is 2, so the period actually equals 4 in this case. So that's a basic help on identifying amplitude and period. Now, the way you could see this structured in what we would consider quote-unquote a real-world problem is through osculating type problems, any types of problems with wavelengths. So when you get into courses like physics and you start dealing with sound waves and light waves and anything that has a oscillating type motion, this is where the sine and cosine curves are going to come into play in a more realistic setting. So but this is a good intro for you and should give you a good running start whenever you get to those types of concepts in those classes.